Okay, so this is our intro into trigonometry, trig for short. When you're dealing with math, for the longest time, you've been dealing with addition, multiplication, division, and subtraction. And those are the four functions of general math, and you're very familiar with those already. Trigonometry has its own functions, which are similar to, saying addition, multiplication, and division and subtraction in general math. So what are those three functions for trig? Well, those three trig functions are the sine function, the cosine function, and the tangent function. And instead of having to write out these words all the time, we like to abbreviate them in trig. And so the abbreviation of those words are as follows: SIN, COS, and TAN. And when we see those, we can say that that represents the sine function, the cosine function, and the tangent function. And these three words or these three abbreviations should seem somewhat familiar. You've probably seen them on your scientific calculators. And if you notice here is my sine button, my cosine button, and my tangent button. And these are the three trig functions for trigonometry. And they're on my calculator, and we're going to discuss what it is that we do with these buttons exactly later on. So, what do the three trig functions tell us to do? We know when we're supposed to add, we know when we're supposed to multiply and things like that. So what do these three trig functions tell us to do? Well, actually, their purpose is related to a triangle. And what they tell us to do is the following. The sine function tells me that I'm supposed to look for the opposite side of a triangle over the hypotenuse. The cosine tells me that it's the adjacent over the hypotenuse. And the tangent function tells me that it is the opposite over the adjacent side. Now these functions are relative to your position on the triangle, and we're going to clarify that a little bit later on. But I just wanted to introduce you to what it is that they do at the most basic level. The sine function is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And you might be saying to yourself right now, well, how am I supposed to remember all of that? Well, first of all, there's a very easy way to remember it, but in case that you don't, it's on your reference sheet. If you look here is a copy of a reference sheet, and if I scroll a little bit down to the bottom here, on the right-hand side, I have my trigonometric ratios, and if you look here, I have the sine, cosine, and tangent function and of angle A. Here's angle A. And it tells me that it's the opposite over the hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And again, like I said earlier, it's relative to your angle. So here we're talking about this angle A, and we're going to get more into that in a second. So you're looking at this here, and you're saying, okay, I know it's on my reference sheet, but there's got to be a shortcut or something better that can help me remember this and make it more functional, right? So how do I remember these three things here more functional? And the way you do it is by using something similar to PEMDAS. If you remember, PEMDAS was please excuse my dear Aunt Sally, and that was for the order of operations, parentheses, exponents, multiplication, division, addition, and subtraction. So the way that we're going to remember what these three trig functions do is by remembering this phrase right here, SOHCAHTOA. Okay, so, S-O-H, ka, with a strong H sound at the end, and toa, SOHCAHTOA. SOHCAHTOA tells me all these three trig functions here without having to look at the reference sheet or without having to memorize this or write it out. The sine function is the opposite over the hypotenuse, opposite over hypotenuse. The cosine function is the adjacent over the hypotenuse. Cosine is adjacent over hypotenuse. And the tangent function is the opposite over the adjacent. Opposite over the adjacent. SOHCAHTOA. And if you can say that to yourself a couple of times in your head, you actually see that it makes sense when you say it. SOHCAHTOA tells you what the three trig functions are. Now, let's clarify how we can use these three trig functions to answer some questions in trigonometry. Okay. Well, first of all, here I have a right triangle. Okay. This is my right triangle. I've labeled my 90-degree angle here. And the first thing that I'm going to do here is, before I can do SOHCAHTOA, or the three trig functions, is I need to label my triangle. Okay? And the way that I label it depends on where my angle is. So if you look here, here's angle X. So everything that we do in terms of how we label this triangle is going to be based upon my angle X. We know this is the right angle, and right now we're focusing on angle X here. Well, if you notice, angle X is right here. Well, the side across from angle X is known as the opposite side. Why is it the opposite? Because it's across from my angle X. Obviously, we know that the hypotenuse is always across from the 90-degree angle, right? There's my 90-degree angle. How to identify the hypotenuse? We've discussed it in class. It's across from the 90-degree angle. So that's my hypotenuse. That's always my hypotenuse. And finally, whatever's left over is known as your adjacent side. So my angle says that, okay, this is the opposite side. This 90-degree angle here indicates that this is the hypotenuse, the longest side of any right triangle, and what's left over is the adjacent side. So now, I've labeled my triangle, and now I can use SOHCAHTOA to write my trigonometric ratios that you saw on the reference sheet and that we have at the top of this sheet here. So let's take a look here. Let's say, for example, that I want to discuss what the sine function is. I want to get the sine ratio of angle X, right? Well, in SOHCAHTOA, the sine tells me that it is the opposite over the hypotenuse. So what's my opposite side here? Well, my opposite side is 3, and my hypotenuse is 5. So the sine of angle X is going to be 3 over 5. And when I take 3 divided by 5, I get 0.6. So the sine of X is 3 over 5, the opposite over the hypotenuse. Here's my opposite, there's my hypotenuse, 3 over 5, and that comes out to 0.6. Let's say we wanted to find the cosine of X, the cosine function. Well, the cosine function says that it is the adjacent over the hypotenuse. Well, where's my adjacent side? Here it is, it's 4. And where's my hypotenuse? There it is, it's 5. So my cosine function is going to be the adjacent over the hypotenuse, 4 over 5. And when I do that, 4 over 5 comes out to be 0.8. So the cosine of X is going to be 4/5 or 0.8. Next, let's take a look at the tangent function. Let's say we wanted to know what is a tangent function of angle X. Well, the tangent functions in SOHCAHTOA tells me that the tangent is the opposite over the adjacent. Well, where's the opposite side? There it is. It's 3. I labeled it. What's the adjacent side? It's 4. So it's going to be opposite over adjacent. Opposite over adjacent is 3 over 4. So the tangent of X is equal to be 3 over 4 or 0.75. And that's pretty simple to begin with. And I'm pretty sure that when you first heard the words trig, you were probably a little bit intimidated by them. But trust me, it's pretty simple, straightforward, as long as you label your triangle. Let's take a look at another triangle. If you look here, whoops. If you look here, I have a right triangle. Again, this is the same right triangle. The sides are the same, 3, 4, and 5. But if you notice now, it's labeled a little bit differently. First of all, I'm not focusing my attention on angle X anymore. Now I'm focusing my attention on angle what? On angle Y. And since this is my angle Y, since angle Y is here, well now the orientation of the sides changes. Since angle Y is here and I'm focusing on it, the opposite side is going to be down here. This is my right angle here, and this is still my hypotenuse. That never changes. We know that the hypotenuse is always across from the 90-degree angle, so that doesn't change. And what's left over is my adjacent side. So remember that we said that trig is relative to the position of the angle. So before, when I had angle X here, it changed how I label my triangle. Now I have angle Y here, so that changes how I label my triangle. Here's angle Y, so there's the opposite side. The 90-degree angle is always across from the hypotenuse, and what's left over is the adjacent side. So now, let's see if we can figure out what the sine function of angle y is, right? Well, the sine function in SOHCAHTOA, if you remember, the sine is the opposite over the hypotenuse. The opposite over the hypotenuse, okay? So the opposite is 4, and my hypotenuse is 5. So my sine of y is going to be 4 over 5, or 0.8. Let's do the cosine function now. The cosine function, well, the SOHCAHTOA, the shortcut tells me that the cosine is the adjacent over the hypotenuse. Well, here's my adjacent, here's my hypotenuse, so the cosine is the adjacent over the hypotenuse, or 3 over 5, which is 0.6. And finally, we have the tangent function. We have the tangent function, and in SOHCAHTOA, it tells me that it's the opposite over the adjacent. Well, the opposite is 4, and the adjacent is 3. So the tangent of y is going to be 4 over 3, or 1.33. So if we look here, depending which angle we're focusing on will determine how we label the triangle. If my angle is here, this is my opposite side, and this is the hypotenuse, this is the adjacent. If my angle is here, this is my opposite side. The hypotenuse, notice, by the way, how the hypotenuse